Hello, students, and all the ATL in charge teachers. In today's online session, we are going to learn more about Arduino, that too Arduino board basics. I know we have been using Arduino for quite some time. However, we are going to go back and learn some basics. We are also going to learn programming, and that is basics of programming through flowchart design. We have been using flowcharts in different subjects, but let's see designing a flowchart from the programming point of view, that too Arduino programming point of view. So I'm sure that you are going to learn more in today's session. So before we proceed further, let's understand Arduino Uno basics. So the left picture is of Arduino Uno board, and it is basically a microcontroller board based on Atmega 328P integrated circuit or microcontroller. That chip is there on this board. So it has 14 digital input output pins, out of which 6 are PWM pins, that is pulse width modulation. I will talk about that later. It also has 6 analog input pins, a USB connection, a power jack, and different headers. So before we go further, as I said, Arduino Uno has Atmega 328P microcontroller. So it is important to know what microcontroller is. So it is a single chip, that is integrated circuit. It is a chip or IC which has everything on it, like CPU, that is central processing unit, random access memory, RAM, read-only memory, ROM, then ADC, analog to digital converter, or DAC, like digital to analog converter. All these functions are packaged onto a single chip, single microcontroller, and that's how the microcontroller are they function. So let's see, as this image talks about. So the CPU, RAM, ROM, serial interface, all the input-output ports, all of them are packaged into a single chip. So the blue outline border, it means that everything is enclosed onto one single chip or IC, and that's how the microcontrollers are. So before we proceed further, it is also important to learn how microcontrollers work, as we have been using Arduino Uno board in our different ATL projects. So what we assemble or what we attach to the Arduino board is basically different input devices like buttons, then switches, sensors, potentiometer, keypad. And what it does is we upload a program through our computer to microcontroller. As per the program or the logic or the process, what it does is it gives output, it gives signals to the output devices like LEDs, buzzers, motors, then LCD display, a speaker, and different kinds of output devices. So today we are going to see the process flow. So there are different types of microcontrollers available in the market depending on the manufacturer. So there are different manufacturers who manufacture these microcontrollers. So Atmega is one of the major manufacturer of the microcontrollers. The Arduino uses that Atmega 328P. The Atmel, then there is something called as ARM. So based on who manufacture these microcontrollers, these are the types of microcontrollers. So it is not important to know them much in detail. However, we would also be interested in to know where are these microcontrollers used. We have been using digital cameras, then smartphones, our household equipments or devices like washing machine, then microwave oven. All these have microcontrollers. Then advanced cars, they have microcontrollers to control their electronic or electrical system. Then medical devices and the gym equipments, all of them use microcontrollers to function. Now, as these images talk about microprocessor, so they're different from microcontrollers. So microprocessor, it has everything as separate unit. The CPU is a separate. The RAM and ROM are attached externally, like the serial interface and input output. All these are attached separately. And microprocessor, the typical example of microprocessor is our computers. So everything is attached separately, right? So the applications of microprocessor are our laptops, our desktop computers, then high-end advanced server computers. The microprocessors are also used in designing or assembling the game designing computers, the animation designing computers. So all these computers need high-end memory, and that's why these memory units are attached externally to the CPU. So now let's go back and understand the basics of Arduino Uno board. So as you can see on this picture, the top 14 pins are digital input output pins along with 6 PWM pins. So these pulse width modulation pins are used to vary the frequency of a motor, to increase or decrease the intensity of LED. Then there is inbuilt LED. As you know that there is one inbuilt LED on the Arduino board. The middle one, there are some pins you can see, that is ICSP pins, that is integrated circuit or inbuilt circuit serial programming. These pins are used to program the microcontroller chip. Then on the bottom you can see the Atmega 328P microcontroller IC or chip. Below that there are power pins like 3.3 volt or 5 volt, and there are 2 ground pins. And the bottom, the very right, there are 6 analog input pins. So these 6 analog input pins are used to give analog inputs to the Arduino Uno board. Now let's see some of the other parts. The top you can see again there are 6 programming pins. There is a reset button. We can reset the Arduino board if there is any challenge, or if you want to erase the program and reset it, you can use the reset button. Then there is a USB connector. The Arduino Uno board is connected to our laptops through the USB connector. Then there are RX TX LEDs. You might have seen these 2 LEDs blinking when the program is getting uploaded, or sometimes when the Arduino sends some commands to the Bluetooth device or receives command from the Bluetooth device. These 2 LEDs blink. And then there is a 5 volt regulator that you can see, and a 3.3 volt regulator. What these regulators do, basically they perform or they do a function or a job of a transformer. They step down the voltage. You can the voltage, that is output voltage from the Arduino, is either 3.3 volt or 5 volt, and then there is a DC barrel jack. We can connect adapter. Now let's make some Arduino circuits and see how we can program them using the Arduino IDE, and at the same time we are going to learn how to do programming or what logic it takes, and we can thus develop the process flow. Then we are going to use the IR sensor today and the LED. So IR sensor, basically you have used it, but let me go back into some more details. The black LED is IR receiver, so it receives, and the white LED on the bottom, it is IR emitter LED. So what it does is, this white LED, IR emitter LED, emits a light, and when you bring your hand in front of the sensor, that light that which has been emitted by the IR emitter LED is struck on your hand, and it goes back, it bounces back, and the IR receiver, that is black LED, will receive that light. Now this is a circuit diagram basically. Then there are 3 pins on the IR sensor. One is VCC, ground, and signal pin. So we have connected signal pin to digital pin 3, and obviously ground and VCC connections, and we are using one LED. We are connecting LED, one terminal, that is negative terminal, to the ground, and positive terminal of LED is connected to digital pin number 13. So this is how our circuit diagram looks like. We don't need a resistor here in this case. Now we will see, we have done Arduino programming before. I'm not going to go into much details of the Arduino program right now, but why I brought this picture in between is just to show that this is a program for Arduino IR sensor and LED. After uploading the program, what it does is, when you bring your hand next to the IR sensor, the LED blinks. When you take your hand off, the LED switches off. So what is the logic? What is the process flow? So IR sensor detects if there is any obstacle in front of the sensor, by the the light emitted by the emitter LED. And what it does is, if there is an obstacle, the status of the IR sensor becomes low, and the Arduino then sends the signal to the digital pin of LED, that is pin number 13 that we have connected, to turn it high or on. If there is no obstacle in front of the IR sensor, then the LED turns off. So these are basic steps or process flow of this particular circuit. Now, before we go into much detail of process flow diagram, let's understand, there are different simple things which we can put it into terms of process flow. So now this case, a tea making. So what is the process flow? Making of a tea, then get the container, what type of container you need, whether it's a plastic cup or whether you need a mug, then fill the kettle or the pot with the water, boil it, add some tea, sugar, and do you need a milk? Yes or no? Then do you want to add a sugar? Yes or no? So depending on how you want to make your tea, you can put or write a steps, to make a tea. So process flow diagrams can be used for anything, right from computer programming to actual work process. So another example of tea making. So what it tells is, whether you want to make a green tea or a herbal tea or just plain black tea, based on these different decisions, so that you can, add different processes, like set different temperatures of, the oven or the kettle. You can set different temperatures. Based on that, you are going to wait for some time in meanwhile, and again, depending on the type of tea, you are going to add different, delay times or wait times for, boiling. And again, as I said earlier, based on you want to add milk or a lemon, you make your tea and enjoy your beverage. So this is a process flow diagram for making tea. So what is, basics of the process flow diagram? The flow chart is simply a graphical representation of steps. It shows steps in sequential order. What comes first, what comes next. And it is widely used in presenting the flow of algorithms, programming algorithms, a workflow or a process. They are used to illustrate the algorithm, to aid in visualizing the program or the workflow. Flowcharts are basically read from top to bottom and left to right in order to follow the process from start to finish. We are going to, see some of the symbols that are basically used in designing or building up the flowchart or designing a flowchart. The symbols are important, as you can see in this table. The meaning and symbol and description. So the oval shape, the green oval shape, or it can be a rectangle with curved edges, that is the start or end of the process. Then the arrow, it tells about, it goes from which direction to which direction. And then the rectangle is about processes. A rectangle or square box, it shows the instruction or the what it does. Then the diamond box represents decision, whether you want to add milk or no, like that. And then there is a delay. That red symbol is delay that you can see. And start or end, again, they are alternate of elongated circle. Those are used as a terminals. And then there are some more symbols, like a circle used as connectors. Then the rhomboid is used as slanted lines, used as input, like for example yes or no. And then there is something called as subprogram within a program. So the steps of flowchart is basically identify your basic steps. And before you go and write your process flow or flowchart, you need to identify what are the major steps in my process or major steps in my program, and based on that you write those major blocks. Then you add some more details, like you key in the details, like for example, fill in those blanks, fill in those steps, and furnish the major blocks with some more details. Once you have written your flow chart in as a first step, you can validate your flow chart, and then you can change it. Now flow chart of IR sensor with LED algorithm. So first step, start, that is terminator or start or end. Then you add a flow line, then an input block. In our case, it is input is going to be IR sensor, and then the next is the decision. IR sensor status low, then it goes to input as yes, or another input of IR status low can be no. And then I'm going to add some connectors because there is no space. So as connector A, if the input IR sensor status is low, if it is yes, LED turns on. If the IR sensor status low is it is not the case, then LED is off, and at the end. So that is the terminator. So let's try to convert it in terms of the Arduino program. In the initial, we define the pin numbers. The IR sensor pin is number 3, the LED pin is number 13. And in the void setup, we basically define the inputs. As we have seen in the process flow diagram, we are going to define the input and output pins. That is, IR sensor is input pin, the LED pin is output pin. Now, next is void loop. So in void loop, what we do is basically we define that sensor status, whether it reads the sensor status, and if the sensor status is low, the LED pin turns high, that is on, else it turns off. It exactly matches with the process flow diagram. Now let's see how the program works. Again, if there is an obstacle in front of the IR sensor, LED turns on. Obstacle is gone, the LED turns off. And it is done in loop, that's void loop. And this is exactly what I have written in my Arduino program. So we have defined the constants, IR sensor as output as pin number 3, LED pin output as number 13. In void setup, we define the pin mode, that is input as per the flow diagram, LED pin as output, then IR sensor pin as input, because it receives the signal from the outside and it gives the output signal to the LED. The next thing is void loop. In void loop, whatever we write, it keeps on repeating. What I have written here is it detects if there is an obstacle, it checks the sensor. If the sensor status is low, then LED is turned on, and if the sensor status is not low or it is high, the LED turns off. That means if there is no obstacle, LED turns off. If there is obstacle, LED turns on. So in case of what I have done is I have added a delay here. As you can see, everything is same right from start to end, but in between I have added delay. So what it does is, when there is an obstacle next to the IR sensor, the LED turns on. So this is the second case. I am talking about a second case. So I have added a delay. The LED, when there is an obstacle in front of the IR sensor, it is a delay. The LED will turn on for 5 seconds. Now let's see. Hand is there in front of the IR sensor. Now LED is on for 5 seconds and it turns off. So you can add multiple things in your code as well as your process flow diagram. Now this part, start and input, are defined in void setup. From decision whether your IR sensor status is low, it checks it, then it gives accordingly it gives signal to LED to turn on or off. All this decision, from decision to end of the process, everything is part of the void loop. So you need to understand this process flow diagram very well. Now the second project that we are going to do, understand the programming and process flow diagram, is LED blinking. We have done this many times, but let me take one LED. I have connected the LED positive terminal to pin number 13 and negative terminal to ground. I am going to connect the USB pin to the USB connector and the other end of the USB cable to the computer. So after all these connections are done, I'm going to first of all see what logic can be. Now I'm opening the Arduino IDE. What it tells is, I'm going to open the example, the new sketch, and void setup and void loop. We have seen it, right? Void setup, we define the pin numbers. The input pin, we define the LED pin number that we define, and in void loop we define the logic. Right now I'm going to upload the program. It gets uploaded without any problem because the syntax is correct. However, there is nothing inside void setup or void loop, and that's how nothing will happen. The upload button will compile the program into machine code and it sends to the Arduino board. However, as I said earlier, nothing will happen because there is no logic or no process flow written either under the setup command or either under the loop command. So a setup function or a loop function, there is nothing written, so nothing will happen uh, to the Arduino board. So what I'm going to write is I'm going to write a code setup in setup because whatever code I write in setup, it executes once because it defines the pin numbers. Whatever I write in the loop function, uh, whatever code I write in the loop function, it executes repeatedly. As long as it receives the signal from input, the Arduino will give signal to the output repeatedly, and that's how the loop function is used in the Arduino IDE, the program. Now let's try to understand this using the flowchart. Whatever I just spoke, let's try to understand, put it in terms of a flowchart visual. So let me start with the terminal start. The Arduino program will start. Whatever you power on the board, it will start, and then the next step is setup in the program. So we define the pin numbers, then we define some constants like input pins, and then there is a loop function. We have talked about it, and it keeps on repeating multiple times in the loop as long as we give power to the Arduino board. So this is how basically the overall process flow happens for Arduino program. Now we are going to see this same thing for LED blinking. So let me try to put the process flow diagram for LED blinking. So first thing is start the program. Then I'm going to define pin number 13 as my output pin, and I'm going to turn this pin number 13 on for 0.5 seconds. After that, I'm going to turn the LED pin number 13 off for another 0.5 seconds, and it goes back again to turn the LED on, and that cycle continues. So from turning the LED, that is pin number 13, on for 5 seconds, off for 0.5 seconds, all this process is repeated in the loop function. So let's put this in terms of the Arduino code, ID code. So setup, I'm going to do some pseudo code, that is setup function, setup pin number 13 as output. Then in loop function, we are going to write a code that is turn LED on, wait for 500 milliseconds, that is 0.5 seconds, turn the LED off for 0.5 seconds, that is 500 milliseconds, and close that loop function. Now setup and loop, we have talked about it, right? So loop, whatever we write, it keeps on repeating. So setup, we have set up pin number 13 as output pin, that is the LED positive terminal of LEDs as the output pin. After that, what I've written in loop is turn the LED on for 0.5 seconds, turn the LED off for 0.5 seconds, and it keeps on repeating in the loop. So this is how the program of LED blinking looks like. Now let me write exactly the same thing in Arduino IDE. So in setup, what I'm going to define is I'm going to define the pin. I'm going to define the pin mode number 13 as the output pin. As I said earlier, the flow chart, we are defining the inputs, right? So what is the pin number 13 as output pin, part of the void setup. In void loop, what we are going to do is digital write pin number 13 high, that is we are going to turn the LED connected to pin number 13, we are going to make it turn, we are going to turn it on, that is high. That is the programming language of Arduino. So high means on, right? So we are going to turn it on. We are going to give a delay. You remember the symbol of the process flow diagram? We are going to give delay of 0.5 seconds, that is 500 milliseconds, then semicolon. Now what we said is after the LED is turned on for 0.5 seconds, we are going to say digital write pin number 13 low. So all these high and low words to be written in capital. Just follow the syntax. So low means we are going to turn the LED off. So what it does is turn the LED on, make the digital pin number 13 high for 0.5 seconds, then turn it off, select the board, Arduino Uno, then select the port, that is COM7, upload the program, done uploading. Now what it does is turns the LED for 0.5 second on, off, on, off. So this is typically the loop function. This is how it works. So we have learned today about the basics of Arduino Uno board. What are different pins? What are they used for? What type of microcontroller is used on Arduino Uno board? We also learned about what microcontrollers are, what are their applications, what is the difference between microcontroller and microprocessor. Then we learned about basics of process flow diagram. We learned about making a process flow diagram of T. Then we did IR sensor and LED, and then LED blinking. For both of these circuits or projects, we defined process flow diagram and their respective programs. After that, we also made the actual connections on Arduino Uno board using the IR sensor and LED. That is was first project, and second part was LED blinking. So the main objective of today's session was basically to learn the different pins of Arduino Uno board, and more than the actual programming, what was more important is to learn drawing a process flow diagram. So what I want you, go back and whatever program you are writing, just simply write process flow diagram first. That is what going to help you in creating or writing the programs. So thank you.